Assalamualaikum and hello everyone. Today we are going to proceed with our discussion for chapter 5 on topic vectors. So in this chapter there are 4 subtopics that we are going to learn. The first subtopic is 5.1 vectors in 3 dimensions, 5.2 scalar product, 5.3 vector product, and 5.4 the application of vectors in geometry. Now let us proceed with the next subtopic on our chapter, which is 5.2 on scalar product. For today's lecture, these are the learning objective and student learning time that you have to achieve at the end of the lecture. The first one is to find the scalar product, the second one to use the properties of scalar product, and the last one to find the angle between two vectors. Now, let us look at the first learning objective for today to understand the scalar product. The scalar product is also known as the dot product. Now, if we are given the vector of A, namely A1i plus A2j plus A3k, and vector B, B1i plus B2j plus B3k, and theta is given as the angle between the two vectors, then the scalar product of vector A and vector B can be defined as such. Vector A dot vector B is equals to A1 times B1 plus A2 times B2 plus A3 times B3. A dot B can also be defined as in the magnitude and also angle form. So the formula is given by A dot B equals to magnitude of A times magnitude of B times cos theta. Now, if you look at this diagram, this is the representation of theta, which is the angle between vector A and vector B. Now, let us look at the angle between two vectors. So, if we are given two vectors, vector A and vector B, then theta, or the angle between vector A and vector B, is defined as theta equals to cos inverse of A dot B divided by magnitude A times magnitude B. If you observe this formula, this is from the rearranging of the dot product that involve the angle between the two vectors. Now, let us look at the first example, example 1. So, if we are given vector A, where A is given by 2i plus 3j minus 4k, and vector B given by negative I plus 2j minus k. Now, we need to find vector A dot B and the angle between vector A and vector B. Okay, so what we're going to have is, first, let's look at the solution. Okay, so the solution is given by, so we want to find the dot product A dot B, right? Okay, so for A dot B, what we are taking is A1 times B1 plus with A2 times B2 plus with A3 times B3. Okay, so our A1 is 2, so we're going to have 2 times negative 1, B1 is negative 1, plus with 3 times with 2, and then plus with negative 4 times negative 1, right? And that is equals to 8. Okay, so if you simplify this, that is equals to 8. That is for part A. For part B, what we need to find is the angle between the vectors, right? So we need to find A dot B. Okay, so A dot B is actually given by magnitude A times magnitude B cos theta, right? This is the formula that we have. So, if we look at from this formula, we can rearrange this to get cos theta is equals to A dot B divided by magnitude A times magnitude B. So, having from this formula, to get our theta, what we can do is we can take cos inverse of A dot B divided by magnitude A, magnitude B. Okay, so this is the formula for the angle between two vectors. So what we already have over here is the value for A dot B. Now we need to find magnitude of A and magnitude of B. So to get to magnitude of A, we need to find the square root of 2 squared, A1 squared, plus A2 squared, 3 squared, plus with A3 squared, so negative 4 squared. Right, so we have it in this form, square root of everything, so that will be square root of 29. Right, so magnitude for vector B is given by square root of B1, so negative 1 square plus 2 squared plus with negative 1 squared. Okay, and then square root of this term. So what we have is square root of 6. So now we already have magnitude of A and magnitude of B. We'll just substitute in our formula. So that is cos inverse of A dot B given by 8. This one will be magnitude of 29 times magnitude of 6. Okay, so finding this value from our calculator, then we will have 52.66 degrees. Alright, so this is for the angle between two vectors.